consider this given problem statement. So it says that let tan A, tan B, where A comma B belongs to this interval, that is negative pi by 2 to pi by 2. So these are the roots of the quadratic equation that is given as x square minus 2x minus 5, that is equal and that is equal to 0. So in this case we need to compute the value of 20 times sine of a plus b by 2 squared plus 3 times square root of 10. So this is the expression which we need to resolve and get the value. Now, so here it is clearly mentioned, it is clearly given that tangent of A and then tangent of B, right, where this A and B belongs to this particular interval, these are the roots of this given quadratic equation, roots of this given quadratic equation, right. So from this we can clearly state that here the sum of roots. So for this quadratic equation, if this tan and tan b are the roots, so in that case I can take sum of roots. So from this I can write that tan a plus tan b, that is sum of roots, as 2, right. So that is sum of roots as minus b by a, right. And the next one, the product of roots. So the product of roots, that is tan a times tan b, this would be negative 5 in this case, right. Now here we'll compute the value of tan a plus b first of all, right, because this tan and tan b is given. So I'll try to use the identity, that is tangent of a plus b, and now this is equal to tan a and then plus tan b over 1 minus tan a times tan b. Now this will be equal to, so tan a plus tan b, this sum of root is already given, that is 2, and this will be 1 minus and then here negative 5, and on resolving this, this is 2 over 6 and 2 over 6 simplifies to 1/3, 1 by 3, right, 1 over 3. Now next, and similarly we can say, so we need this quantity, right, that is sine a plus b squared, right. So first of all I'll try to extract out this sine of a plus b, right. So I need the squared quantity, so I'll just square this up, and this one can be written in terms of tan, that is tan square x, that is a plus b in this case, 1 plus tan square of a plus b. Now I'll just plug in the values. So this one is already 1/3. So on the numerator, so here I will write the square of 1/3, and here 1 plus, so here this will be square of 1/3, not cube, and this same number will be required in the denominator as well. Now on resolving this expression, I will be getting 1 over 10. Now once this part is done, so we can say that we are also aware of this fact that if I have sine of half of the x as squared, so this is nothing but 1 minus cosine of x by 2. This is the identity which we are aware of, right. And even from sine 2x we can derive this part, right, using sine 2x then cos 2x, using these identities we can definitely derive these parts. Now getting to the next step, so from this we can say that, so, and if you observe this cos a plus b, right, so this is square root of 1 minus sine squared a plus b. So from this I will be able to compute this. So why do I need to compute this cos a plus b? Because here when I'll substitute for this x as a plus b, so I will also require the value of this cosine of a plus b, and hence I am proceeding with this particular step. So this one is 1, and this sine a plus b squared is already computed as 1 over 10. So I'll just plug in this particular value here. Now on resolving this expression, I'll be getting 3 over square root of 10, right. Now after this, so we can say thus, that is sine of a plus b squared. So this is the quantity that I need. So thus this would be equal to, now this value is something that we are already having. So here I'll be using this particular identity. So instead of x, I'm clearly having here a plus b, right? So I'll remove this x and I'll be writing the angle a plus b. Now I'll replace this value of cosine of a plus b which we have computed here. So I'll be taking this value and then substitute instead of this particular expression. Now on resolving this, so I'll be resolving this in the later stage. So let's keep it as it is. So this is clearly square root of 10 minus 3 over 2 times square root of 10. Anyways, I'll be resolving this in the next step. So what I'll do here, so this is the expression that we need to compute, right? So I'll copy this expression as it is and put it over here. Now, so this is the value, this value is something that we already have. So I'll just take this particular expression and plug it here within the parenthesis. Now, on resolving this expression further, on resolving this, so definitely this 2 and 20 becomes 10. So square root of 10 is the denominator. On resolving this, I'll be getting 10 minus 3 times square root of 3 and then plus 3 times square root of 10. Now this positive and negative same quantity gets cancelled out and hence our output is 10. So for this one, the answer is 10 and hence it is solved. So this is the problem statement and our answer is